Today on Maths Sparks, our topic is Surds. Uh, this topic, Surds, has recently been added in the O-level syllabus. Although the students who have studied Maths, they must have done it. So let's start up. Surd is is an expression involving unresolved roots of the numbers. We all have done square roots in the junior classes. Basically, square root 2, square root 8, square root 108 are the examples of surds. Square root 25. Now, we know if we take the square root of 25, it is 5. And then 81 is a perfect square, so it's going to give us 9. 169 is again a perfect square, it's going to give us 13. Whereas, if we take square root of 8, we do not get an integer. Rather, in the calculator, we can have numbers in decimals. So basically, the surds are as we have studied here, they are the unresolved roots of the numbers. So the numbers who are not the perfect squares, when we take the square root of them, then we say that they are called the surds. Okay, this is the basic definition. People can quickly go through it. There are some laws of surds, multiplication, the square root numbers. Um, when we will do the examples, you will have a better idea of these laws. Okay. To simplify surds, we have to split the number into factors involving square numbers. For example, the square root of 8, we can resolve it in the form of a pair of factor 4 cross 4 multiplied by 2. Now we know square root of 4 we separate out as per our law. if- As per our law, that can be separated out. Square root 4 into square root 2. The square root of 4 is 2, and square root of 2 remains as it is. So it means 2 root 2 is our answer. There are some rules for the multiplication of surds and other thing. Like if we check out here, square root of 3, root 3 multiply root 5. So as per our rule, we can write it down like in a single square. So it means 3 5s are 15. Eventually we get the answer of square root 5. Next thing, 2 square root 3 cross square root 2. 2 multiply 4, square root 3 into 2. 3 to 2 is 6, again root 6. It cannot be further done, so that is our answer. Whereas we must have an idea that if there is a plus sign, we will see in further, then this 3 and 2 cannot be added on. But in case of multiplication, we can multiply it. Okay, then we have division of surds. There's the rule and square root of 18 divided by square root. We can write it down in a single big root, 18 upon 2. Then after doing the cancellation, 2 ones are 2 and 2 nines are 18. Now square root 9, obviously it's a perfect square, so square root of 9 is 3. That's the that's how we can get our answer. Next thing, addition and subtraction. Uh, we are going to again move on to the examples, like over here, uh, going through example, the first example, that is the example for the addition. Okay, 5 root 7 plus 3 root 7. Now if you remember the way we do in factorization, taking common, we take the like term common or the like variable common. So over here, the first term contains square root of 7, second also contains square root 7. So what I'm going to do, I'm going to take square root 7 common. Left inside is, okay, we are left inside with 5 plus 3. So square root of 7 multiply 5 plus 3 is 8. But you must remember that square root numbers should be written after the numbers without the square root. And like this, a student might do this mistake. They put square root over 8 also, which will go wrong. So we can write it down this as 8 root 7, the way they have written here. Okay, so this is how we have done. Next, moving on to the Second example with subtraction. Again here 10 root 2 minus 4 root 2. Here the common is square root of 2. Left hand side is 10 minus 4. 10 minus 4 gives us 6. Now this 6, the writing pattern is this, 6 will come first and root 2 will come later on. So that is our answer for the subtraction thing. Okay, they have added up here that square root, you cannot add root 2 plus root 3. Means while adding or while taking common, it must be the same thing which you can only take common. Multiply, now here we are going to learn another concept involved in the topic of surds, a very important one, that is rationalize. For rationalize, the questions comes in different way. This is the first example for the rationalization, that you have to rationalize 2 upon root 3. In rationalize, we multiply and divide by the denominator. Over here, our denominator is square root of 3. So we will multiply by square root of 3 and divide by square root of 3. Now, in the numerator, 2 root 3. Then in the denominator, as we have studied, this goes for numerator. In the denominator, root 3 multiply root 3. As these are the same thing, in the multiplication, in the previous rule, we have studied that we can write it down in a single root, that is 3 into 3. Now, 3 into 3, if we take the square root, we can directly get the answer 3. Or you can understand 3 into 3 is 9. It means it can give upon 3. That's how you're getting the answer. Okay, it's not always necessary that you make 3 into 3 as root 9. We can consider it in an other way. That other way, like with this step, 2 square root 3 by 3 square. This can cancel and we can get 2 root 3 over 3. And there is a simple direct way also. The direct way is this, 2 root 3 upon 3. We know that when these three same are going to multiply, it's going to be a perfect root. So it depends on a student which way you want to adopt. Okay. Now check out here. In the denominator, it is 3 square root of 7. So we are going to multiply by root 7 and root 7. It's not so that we should multiply by 3 also with it. Just the surd. We are going to multiply and divide by the surd. And this concept is quite clear, that 3 7 is 21. And then same thing over here. How we got this 7? We have already done the explanation, like 5 root 7 upon 3 root 7 multiply root 7. It means 5 root 7 upon 3. So 5 root 7 upon 3. Now we know that 7 square is 49. 7 7 is 49. Square root of 49 is simply 7. So 5 root 7 upon 3 7 is 21. That is how we are getting this answer. Okay. Then we have the binomial surds. Uh, there is a word conjugate. Conjugate in simple language you can understand as the opposite. Like a plus root b. The opposite or the conjugate of this is a minus root b. Then a minus root b conjugate is a plus root b. Just the sign in the middle is changing, right? If you need the opposite of it, you need the conjugate of it. Simply the sign is changing. Okay, so after the concept of conjugate, the very important concept is the third identity. If you remember, we have done third identity in the junior classes, that is a square minus b square, a plus b, a minus b. Over here, they have written x square minus y square, x plus y, x minus y. Using up this identity is going to be used quite many times by rationalizing the binomial thirds. A plus root b, a minus root b. So your x is a and your y is root b. So that is how it becomes x square minus y square, means a square minus root b square. Now root b square, again we must have an idea that this is power half. Square root means power half. These two can cancel and we can get only b. Or we can directly know that if we take the square of a root, it will cancel and you will get this answer. Now let's come to the rationalization. 1 upon 2 plus root 2, root 3, we have to rationalize it. The conjugate of this is, remember I told you just change the sign. So multiplying and dividing by the conjugate, that is 2 minus root 3 upon 2 minus root 3. Ones are, it's giving this. Okay, here we have used this third identity, that is our x square minus y square. 2 square gives us 4. How we are getting this x square minus y square? Let's do a simple step here. 2 minus root 3 upon 2 plus root 3, 2 minus root 3. So check it out. The first one is a plus b, rather x plus y. The second one is x minus y, and we get x square minus y square. Then solving 4 minus 3 is 1. So as it is 1, so we are left with the numerator only. Denominator comes 1, and as we can make it an invisible one, so 2 minus root 3 is our answer. Okay. Here are some more examples of our for the multiplication or resolving the surds. Square root of 108. You remember I told you to take factors. So 9 twelves is 108. Then separating out root 9 and root 12. 3 multiplied by 12. Now, one important thing to remember is this 3 root 12 is not in the ultimate answer because it can be further turned into the product of factors. So root 12 can be written as 4 cross 3. Then separating out, we can take square root of 4 and square root 3 left us with a surd. So 6 root 3 is our answer. So this is an important point to remember. Then here are some basic examples. We have already done this thing. Then there's another example for 2 over root 18. You remember we have to multiply and divide by the denominator. So our numerator and denominator, root 18 upon root 18. Then we get 18 is the denominator, solving out, resolving it into the lowest factors. We are getting square root 2 upon 3. Then this is another example for the rationalizing. 5 plus root 7, multiplying and dividing by 5 minus root 7. Okay, this is another method. I just want to show it to you, but like they have multiplied this, then this, then this, then this. But I would prefer using up the third identity. This method, the multiplication, can be used if a student doesn't remember the identity. Rather than that, the better thing is this, you must consider it as a plus b, a minus b. So we can say that a square minus b square, or a is 5 and b is root 7. So check out, we will directly have this answer. 3, 5, 5 square is 25, root 7, square of root 7 is 7, and we can directly get 25 minus 7. So this multiplying the denominators, there is a method for this, but go for using up the third identity. That's far better. So with this, we end our topic of search. One thing, how we get this 6, let me quickly explain this, how we are getting this 6. 3 ones are 3, 3 fives are 15, 6. That is how we are getting this 6. 3 was outside the bracket, so that's why we can cancel it. Okay, so here we end up with the topic of search. Best of luck.